had a look at the chemical reactions involving our alkali metals. The first reaction we said with oxygen, what was the product? An oxide. When the metals reacted with water, the product was a hydroxide. And when they reacted with one of the halogens, we got a salt. That would be, in this case, if it was with chlorine, the salt was a chloride. No? Okay. Now, I am done with those chemical reactions. The next thing that we have to have a look at is something new, all right? It is the so-called flame test. Now, what they very basically do is, if they have a compound or the pure metal containing a metal, what they're going to do is they go and burn that. They heat it up in a flame. Because specific metals burn with a very specific color of flame. And this can be used to identify which metal we have. So just very simply, it's called a flame test. And if we have a look at the group 1 metals, what they're basically going to do is they use a clean platinum wire. Okay? Now, do you think they are ever going to ask a flame test in a practical exam? If I have to order 10 platinum wires, I am definitely not going to leave them in the school. I'm going to sell them, because platinum is very expensive. Okay. So, you need to just know the test. They can ask it. The chances of you doing it practical, I don't even think we did it in our first year chemistry at university, a flame test. Because the platinum wire is very, very expensive. Maybe at a mine, for example, at B2 Gold Mine, in their laboratory, where they test the salts, the ores that they dig up to see what type of metals they are, there you might find some platinum wire. All right. Why do they use platinum? It's unreactive. Very important. Can take very high temperatures, and it's unreactive. So it won't melt when you stick it in the flame, and it's not going to react and give you a false positive for whatever. You understand? Or negative. No? All right. So they take a clean platinum wire. It's dipped into some hydrochloric acid. The hydrochloric acid dissolves any impurities on the surface. All right. And then it's dipped. Well, they heat it up with the hydrochloric acid, and they dip it back, and they heat it, and they dip it back until at a point they decide, okay, now the platinum wire is perfectly clean. There are no contaminants on it. Then they go and they dip the platinum wire into the salt sample. Now, what is a salt? It's yes, it's a compound consisting of a metal bonded onto a non-metal. And then they go and hold this compound that sticks to the tip of the platinum wire into the flame of a Bunsen burner. Please remember, we need a more noisy blue flame. Is a flame that burns pure. Okay? Yes. Who knows what an oxyacetylene blowtorch is? Yes. If you open up the acetylene, you light the flame. What color flame is there? First, yellow, smoky, ne? And then you open up the oxygen, and then, what is it? Can you hear the flame? It goes, ne? A noisy blue flame is a clean burning flame. If I have a yellow smoky flame, it's going to make carbon, which can contaminate or give you a false positive, because carbon glows and burns with an orangey flame. Okay, so we need a noisy blue flame, and you will hold that platinum wire that is coated with the salt that you are testing in a flame, and the color of the flame produced will tell you what salt we have. Now, your syllabus specifies you need to know that lithium burns with a red flame. Let's see if I can get some orange. There's some orange. Sodium will burn with an orange flame, and potassium will burn with a lilac flame. If you are asked, or they give you a question, they say an unknown compound, a flame test is done on it, and the color flame you get is red. What metal do you probably have? Lithium. All right. After lithium, sodium is orange, and potassium is purple. Now, potassium is easy to remember because potassium, if we have potassium permanganate, that's the purple crystals that dissolve in water and make the water purple. So potassium is purple, a lilac flame. All right. Lithium, you'll just have to go and remember that one. And sodium, yeah, that one you also have to go and remember because the metals are all shiny metals. All right, silvery, shiny metals. So you can't deduce from what the metal looks like what the flame will be. Okay, so here we have some new information. The flame test. All right. Now we are finished with the group 1 metals. Now the next group that we are going to have a look at are the alkali earth metals. They are group 2 metals. Now, because they are metals, they are shiny, malleable, ductile, sonorous, good conductors of heat, good conductors of electricity. Those are general metallic properties. But what makes them different from the other metals? If we go and have a look, they have got similar properties to group 1. Now, what were group 1 metal properties that were different from the other metals? They are soft. They have low densities and low melting and boiling points. All right. So they have similar properties to group 1. But what do they have different from group 1? They have 2 outer shell electrons. If they have 2 electrons in the outer shell, what charge will they have on the iron? If it forms an iron, it's going to lose 2 electrons. It's going to become positive. Remember, if it loses negative electrons, you are left with a 2+ charge. So all the ions in group 2 are +2 ions, meaning they've got 2 bonding places. No? All right. They form white salts. Now, this is actually quite important. Group 1 elements also form white salts. Like table salt is a white salt. Do you understand? Okay. Now, group 1 and 2 elements all form white salts. The group 1 salts are all soluble. Okay. But the group 2 salts are not that soluble. They are only slightly soluble in water. Okay, so group 1 is more soluble, group 2 is slightly less soluble. The reactions of the group 2 elements in the first case with water, what would the product be when a metal reacts with water? The hydroxide. Okay, remember the group 1 metals. It's general, these reactions, people. If group 1 metals, when they react with water, form a hydroxide plus hydrogen, what must the group 2 metals form? The same. All right. So we say magnesium is very reactive. It reacts very slowly with cold water. You will see tiny little bubbles forming, but it'll be fairly slow. But if I had hotter water or steam, the reaction is very vigorous. It happens quickly. Okay? Calcium reacts rapidly with water. Calcium is more reactive than magnesium. Remember on the periodic table, we said what happens to the reactivity of the elements? They increase as they go down. That is why magnesium will react slowly with cold water, but calcium will react rapidly. It's more reactive. Here we've got magnesium and calcium to write the equation. Magnesium plus water must give me magnesium hydroxide plus hydrogen. Why do I write hydroxide like that? You should know. Hydroxide has 1 bonding place. And magnesium has 2. So I need 1 magnesium but 2 hydroxides. And I put the hydroxide in brackets because they go together, the hydroxide part. We must balance this equation. 1 magnesium, 2 hydrogens, 4 hydrogens. Do you agree with me? Because remember, this 2 on the outside means I've got 2 of that and 2 of that. So I've got 4 hydrogens there. Here I only have 2, so I will probably need 2. Now, how many oxygens have I got over there? 2. How many oxygens do I have over here? 2. Now it is balanced. All right. Calcium plus water. Yes, I must also get calcium hydroxide. Can you see? Same formula. Why? These are group 2 metals. They have 2 bonding places. All right. The hydroxide only has 1 bonding place, so we need 1 metal but 2 hydroxides. Plus, which gas do we get? Hydrogen gas. And if we balance it, we will find it would be exactly the same. All right. Remember, elements within groups have similar properties. Okay. They say both the formed hydroxides are only slightly soluble in water. All right. You would probably, if you leave the test tube to stand overnight, the next morning there will be a whitish substance in the bottom of the test tube. Okay, that would be the calcium or magnesium hydroxide. That is slightly insoluble. No? The test for hydrogen, we've had that previously as well. A burning splint makes a popping or whistling sound and it burns with a blue flame. That's the positive test for hydrogen. How will I see hydrogen is being formed? You will see bubbles because it's in a liquid. Remember, hydrogen is colorless, odorless, tasteless. So you can't see the gas, but you can see bubbles. And we know if we see bubbles in a test tube, then it implies there is a gas inside it. Okay, so we can catch up the gas and then we can test which gas we have. Slightly water soluble. It does dissolve. You could say, I would say aqueous. Okay, they won't penalize you on that. AQ, water soluble. Even though it is only slightly. All right. The next group 7 elements. The name of the group 7 elements are the halogens. Okay. Starting at the top, fluorine, chlorine, bromine, iodine, and astatine we don't work with. What do we know about the halogens? They are all diatomic. They lie in which group? 7. So how many outer shell electrons do they have? 7. If they have 7 outer shell electrons, how many bonding places do they have? From 7 they want to fill up to get 8, so it only has 1 bonding place. All right. So 7 electrons in the outer shell, it forms ions with a charge -1. Why? If it contains 6 electrons, it's going to gain 1, and an electron has a negative charge, so it will have an extra negative charge. Okay, so the charge on the ion is -1 because it has gained 1 electron to fill the outer shell. Okay. Trends in color and reactivity and melting and boiling point. If we look at our periodic table over here, fluorine, chlorine, bromine, iodine, astatine. Can you remember the periodic table has 2 liquids? The one is mercury and the other one is bromine. So we know that's a liquid. What do we know about fluorine and chlorine? They are gases. And iodine is the one that is a solid. So what do we know about melting and boiling point? It's going to increase. Because here we have gases which have low melting and boiling points, and there we have a solid which has a higher melting and boiling point. So there's a trend in melting and boiling point. There is a trend in color as well. Fluorine is yellow. Chlorine is a green gas. Bromine is a red-brown liquid, and iodine are dark purple-black crystals. Okay? So we even find that the color becomes darker. Now in general, what would you expect would be more reactive? A gas or a liquid or a solid? A gas. For particles to react, the atoms must be separate. Okay, in solids they lie close together, so if I want solids to react, I usually grind it up to make it fine so the particles can be exposed on their surface. Now gas particles are already separate. So gas particles will be more reactive than solid particles. So reactivity. Fluorine is more reactive than chlorine, and chlorine is more reactive than bromine, and bromine is more reactive than iodine. Which is the least reactive? Iodine. Which is the most reactive? Fluorine. And this is very, very important. Okay, so just let's go and look at our notes here. As you go down the group, the color becomes darker. We go from yellow to green to a reddish brown to a purple black crystal. Now, I've written a note in here. Iodine tends to confuse a person. If I have a container with iodine crystals, they are a very dark, almost black color, but if you look at it, you will see it's actually, if you look in the light, it's actually a purplish black color. If I take iodine crystals and I heat them up, they undergo sublimation and the vapor that forms is purple or lilac. Alright? The moment I take iodine now, it's not very soluble in water, but it does dissolve in alcohol. If I dissolve it in alcohol and alcohol dissolves in water, then I can eventually dissolve it into water. So a solution of iodine has got a reddish brown color. What's the color of betadine ointment? Brown ointment. You know what I'm talking about? Have you seen in the movies when they do an operation, they wash the person's body with a reddish brown liquid? It's a liquid containing iodine. Alright? Now this is very confusing because in biology, when you work with iodine, you work with iodine solution and it's a reddish brown. But in the science class, I go and tell you iodine is a dark purple black color. But this is the difference between the crystal, the solid, and the substance when it dissolves in alcohol and water. Okay, so don't let it confuse you. Just take note. Iodine, the crystal, they are purple-black. But the moment I dissolve iodine in a solution of alcohol or water or whatever base, it has a reddish-brown color. And then you want to go and confuse it with bromine, but bromine has a red-brown color originally. Do you understand? Okay, so just take note of that because it does definitely throw you off. Now, the reactivity of the elements decrease from top to bottom. We've already said gases are more reactive than solids, just in general. And we find that melting and boiling points will increase because solids have higher melting and boiling points than gases. So as we go down the group, the melting and boiling point increase. If melting and boiling points increase, what does it tell you about the forces between the particles? They become stronger because to make it melt or boil, you need to overcome those forces. And if it's got a higher melting and boiling point, those forces are stronger. Okay? All right. Now, we must have a look at a couple of the chemical reactions. Now, all of group 7 elements, they like reacting with group 1 and group 2 metals. All right? So sodium will react with iodine, and I will get sodium iodide. Calcium will react with fluorine, and I will get calcium fluoride. Are you with me? We've actually done those reactions when we did the group 1 reactions with the chlorine. Are you with me? Okay? So group 1 and 2 like reacting with group 7. And they form salts. And in general, those salts are white, and they are usually water-soluble. Now, a specific reactivity series exists among the halogens. We've just said fluorine is the most reactive, and iodine is the least reactive. Now, the rule says, and this rule works with metals as well, it says, a more reactive element can displace a less from its compound. Big mouthful. A more reactive element, okay, or rather this one would be a better example. A more reactive element can displace a less reactive one from its compound. So I am going to end up with potassium chloride and bromine. Perfect. There you've got it. Okay. Let's have a look at these reactions. I've just written up a couple of them. Is bromine more reactive or less reactive than chlorine? Less reactive. Is there going to be a chemical reaction? Nope. Why not? A less reactive one can't displace the more reactive one. Do you follow me? Okay. Look at the next one. Here we have got bromine and bromine. Are we going to see a reaction? No. There probably won't be any reaction because the rule says the more reactive one can displace. Not light will displace light. No. Yes. It's just going to stay. This one will have a reddish brown color because of the bromine. Sodium chloride is colorless. This one will also have a reddish brown color. It's not going to change. If we look at this one, bromine and iodine, which one's more reactive? Bromine. Bromine is more reactive. It is going to displace the iodine, and we are going to get potassium bromide. All right. Now, once again, this one is going to be masked a little bit because iodine in solution has a reddish-brown color. Do you understand? Okay. So in solution, you won't really be able to notice the color change. If you look at this one, chlorine and fluorine, can there be a reaction? No. Chlorine is less reactive than fluorine, so there will be no reaction. But over here we will get a visible color change as well. Chlorine is a greenish colored gas. You bubble it through potassium bromide. What's going to happen? You are going to get the formation of bromine, and bromine has a reddish brown color. So your test tube is going to turn from colorless to reddish brown. Okay, potassium chloride is also colorless. Are you with me? This, people, is very important. This rule tells me a more reactive halogen can displace a less reactive halide. What's the difference between a halogen and a halide? No. Or, well, that's what you get in a compound because it's in the ion form. If I have fluorine, that is the halogen. But if I have fluoride, that is the halide. Okay. So the more reactive halogen can displace the less reactive halide. Bromine is going to displace iodine. So we will get potassium bromide and iodine. It doesn't matter in which order you write them. NaBr, yeah, right, okay. Sodium bromide. We can try and balance one. I'm quickly going to wipe the screen. Okay, have a look. We said, will this one react? No. Will this one react? No. Will this one react? Yes, bromine and iodine. We are going to get sodium bromide plus iodine. Okay, now we must balance it. How many bromines? 2. How many bromines? 1. So we will need 2. Okay. How many sodiums? 1, but there we have 2. So I will need 2 over there. How many iodines? 2. And how many iodines? 2. Now it's balanced. You follow? Okay, we can quickly do the transition elements as well. They're not so difficult. Now, the next group then that we have to have a look at are the transition metals. We said they form this group between group 1 and 3, and they lie from period 1, 2, 3, 4, 5, 6, 7. So period 4, 5, 6, 7 contains a special group of metals known as the transition metals. All right? Now, they are not ordered into groups like group 1 and 2 metals. They form a whole horizontal block of elements. They are also known as the heavy metals. Why? What are group 1 and 2 known for? Being less dense, lighter. Okay. So the transition group of metals are heavier. They are, in other words, also more dense. They will have high densities. Okay. General metallic properties: shiny, malleable, ductile, sonorous, good conductors of heat, good conductors of electricity. All metals are like that. But what makes them different? They have high melting and boiling points. What do group 1 and 2 have? Low melting and boiling points. You understand? They have high densities. What do group 1 and 2 have? They have low densities. Now, another thing, and this we will explain a little bit more when we get to the work, when we do it. If we go and have a look at the number of bonding places, we find very often that these transition metals can have varying amounts. For example, iron can be in the form of iron 2, or it can be in the form of iron. Now, don't worry about that too much. Just sort of take note of this characteristic. We say it has more than one valency. Now, valency is just another word for number of bonding places. Okay, number of electrons that it can lose. More than one amount. Okay. Oxidation state, when something loses electrons, the process is known as oxidation, is a loss of electrons. So we say it can have more than one oxidation state. So copper can be copper 1 or copper 2 plus. Iron can be 2 or 3 plus. Do you follow? When we do specific reactions with metals, we will come back to this and I will tell you. For example, if I have got iron chloride, which one do I have? Well, we should write it more properly. Iron Roman numeral 2 chloride. Or I can write it as, what do the Roman numerals tell me? What the oxidation state is. Or valency is. Do you follow? Okay. You all right with that? Alright. Then, valency simply refers to the number of bonding places an element has. They form colored compounds. Copper salts are reddish, bluish green. Iron salts are red and green. Nickel salts are often red. Chromium salts are orange. I don't know all of them. It's just the more well-known ones. Okay. Rust is red, reddish brown. Okay, you get a paint, red oxide, that you paint on stuff to prevent things from rusting. Now, in that paint, there is a more reactive metal than iron. And when the iron starts rusting, it displaces the iron from its compound, so the iron can't rust. Okay. That's on the reactivity series. We'll have a look when we do a topic on metals. We'll have a look at that reaction. Okay, so they form colored compounds. There are some of them that form white salts, but they, in general, group 1 and 2 metals form, all of them form white salts. There aren't any colored salts. Okay, but in the transition elements, mercury oxide, for example, is a bright orange color. All right, so they form colored compounds, and we use them very often as catalysts in industrial processes. Now, part of our syllabus is to do the Haber process. There they use iron as a catalyst, and the contact process is the process whereby we make sulfuric acid. It contains, or they use vanadium oxide as a catalyst. All right. So the transition metals, how do they differ from other metals or from the group 1 and 2 metals? The high densities, high melting and boiling points form colored compounds and are often used as
In a time of uncertainty, false news, and fear, learn on while the world